The world stands at the precipice of a new era of warfare. Ballistic and hypersonic missiles represent a quantum leap in weapon technology. These missiles are not mere upgrades, they are game changers. Their speed and destructive power could reshape the geopolitical landscape. Ballistic missiles with their high arcs and tremendous speeds have long been a concern. Now, hypersonic missiles add a new layer of complexity, traveling at more than 5 times the speed of sound. These weapons compress reaction time. They leave little room for defense. The threat is not merely theoretical. Nations are actively developing and deploying these advanced weapon systems. This proliferation of hypersonic technology raises profound questions about global security. The stakes are incredibly high. The future of warfare is upon us. It is a future defined by speed, stealth, and unprecedented destructive potential. The world must find ways to adapt to this new reality. The alternative is unthinkable. Hypersonic weapons are defined by their blistering speed. They travel at Mach 5 or faster. Imagine an object traveling at 1 mile per second. That's hypersonic. This speed creates unique challenges for both offense and defense. At such speeds, the friction between the missile and the air generates intense heat. The missile must be built to withstand temperatures that would melt conventional materials. This heat also creates a plasma sheath around the missile. This plasma can interfere with communications and make the missile difficult to track. Maneuverability adds another layer of complexity. Unlike ballistic missiles, which follow a predictable trajectory, hypersonic missiles can change course in flight. This makes them incredibly difficult to intercept. They can weave and dodge, evading even the most sophisticated defense systems. The combination of speed, heat, and maneuverability makes hypersonic weapons a formidable challenge. Designing, building, and deploying these weapons pushes the boundaries of physics and engineering. This technology has the potential to upend the balance of power on a global scale. Detecting a hypersonic missile is like trying to spot a bullet in flight. These missiles travel at speeds exceeding Mach 5, which is over 3,800 miles per hour. At such velocities, they can cover vast distances in mere minutes, making early detection incredibly challenging. Their speed gives defenders very little time to react. The window for interception is extremely narrow, often just a few seconds. This necessitates rapid decision-making and immediate action, which puts immense pressure on defense systems and personnel. Traditional radar systems, designed for slower-moving objects, often struggle to acquire and track these weapons. These radars were built to detect aircraft and conventional missiles, which move at much slower speeds compared to hypersonic missiles. The curvature of the Earth poses another challenge. Ground-based radars have a limited line of sight. As the missile travels at low altitudes, it can easily disappear from radar coverage, making continuous tracking difficult. By the time a hypersonic missile is detected, it may be too late to intercept. The missile's high speed means it can close the distance to its target rapidly, leaving minimal time for defensive measures to be deployed. The missile's low-altitude flight path further complicates detection, as it can blend in with ground clutter and other objects. This low-flying trajectory allows it to evade radar systems that are optimized for higher altitude threats. Adding to the difficulty is the potential use of stealth technology. By absorbing or deflecting radar signals, hypersonic missiles can become even harder to detect. Stealth technology reduces the radar cross-section, making the missile appear smaller or even invisible to radar systems. This combination of speed, maneuverability, and stealth makes them a significant challenge for existing defense systems. Hypersonic missiles can change their flight path mid-course, making it difficult to predict their trajectory and intercept them. The ability to detect and track these weapons is crucial for developing effective countermeasures. Early warning is essential. Satellite-based systems and advanced radar networks are being explored to provide the necessary early detection capabilities. New radar technologies and integrated sensor networks are being developed to address this challenge, but the race is on to stay ahead of the threat. Engineers and scientists are working tirelessly to innovate and create systems that can keep up with the rapid advancements in hypersonic technology. Section 4. The arms race intensifies, Russia and China's hypersonic ambitions. In recent years, the global landscape of military technology has been rapidly evolving, with hypersonic weapons emerging as a focal point of this transformation. The development of hypersonic weapons is not limited to a single nation. These advanced weapons, capable of traveling at speeds exceeding Mach 5, are being pursued by multiple countries, each aiming to gain a strategic edge. It is a global endeavor with Russia, China, and the United States leading the charge. These nations are investing heavily in research and development to perfect their hypersonic capabilities, recognizing the potential game-changing impact of these weapons. This technological competition has sparked a new arms race, one with potentially destabilizing consequences. The speed and maneuverability of hypersonic missiles make them difficult to detect and intercept, raising the stakes for global security. Russia has been particularly vocal about its hypersonic capabilities. President Vladimir Putin has frequently highlighted the advancements in this field, positioning Russia as a leader in hypersonic technology. It has already deployed hypersonic missiles such as the Avangard, which can reportedly reach speeds of up to Mach 27. This missile is designed to evade missile defense systems, making it a formidable addition to Russia's arsenal. China too is making significant strides in hypersonic technology, testing and developing its own arsenal of these advanced weapons. The Chinese government has been relatively secretive about its progress, but reports suggest that they are rapidly closing the gap with the United States and Russia. These developments are a clear indication that hypersonic weapons are no longer a futuristic concept, they are a reality. The successful tests and deployments by these nations demonstrate the operational readiness of hypersonic technology. This new reality has prompted concerns about a potential arms race in the Asia-Pacific region and beyond. Countries in this region are now considering their own hypersonic programs or strengthening their missile defense systems in response. The proliferation of hypersonic technology has the potential to reshape the geopolitical landscape. The strategic balance of power could shift, leading to new alliances and rivalries as nations seek to protect their interests. It underscores the need for international dialogue and arms control agreements to prevent an escalation of tensions. Diplomatic efforts must be intensified to establish norms and regulations governing the use of hypersonic weapons. The stakes are simply too high to ignore. The international community must work together to ensure that the pursuit of hypersonic technology does not lead to unintended and potentially catastrophic consequences. Section 5: Stealth and Precision Advancements in Missile Guidance and Evasion. In recent years, the field of missile technology has seen remarkable advancements, particularly in the areas of guidance and evasion. These developments are not just incremental improvements but represent significant leaps in capability and sophistication. Hypersonic weapons are not just about speed. While their ability to travel at speeds exceeding Mach 5 is impressive, it's their integration of advanced technologies that truly sets them apart. These weapons are designed to outpace and outmaneuver traditional defense systems, making them a formidable challenge for any adversary. They also incorporate advanced guidance systems and stealth capabilities, making them even more difficult to counter. Modern guidance systems use a combination of sensors, algorithms, and real-time data to adjust the missile's trajectory mid-flight. This ensures that the missile remains on course, even in the face of countermeasures and evasive actions by the target. These technologies are constantly evolving, adding new layers of complexity to an already challenging problem. Engineers and scientists are continually working to refine these systems, incorporating the latest advancements in artificial intelligence and machine learning to enhance the missile's decision-making capabilities. Advanced guidance systems allow hypersonic missiles to make in-flight course corrections, enhancing their accuracy and making them less predictable. This unpredictability is a key factor in their effectiveness, as it complicates the task of intercepting the missile before it reaches its target. They can use a combination of GPS, inertial navigation, and terrain contour matching to navigate to their targets. GPS provides precise location data, while inertial navigation systems track the missile's position and velocity. Terrain contour matching allows the missile to compare its surroundings with preloaded maps, ensuring it stays on the correct path, even in GPS-denied environments. This precision targeting capability reduces the margin of error, making them incredibly effective weapons. The ability to hit a target with pinpoint accuracy minimizes collateral damage and maximizes the impact on the intended target, whether it's a strategic military installation or a high-value asset. Stealth technology further complicates the defense equation. By incorporating materials and designs that absorb or deflect radar waves, these missiles can significantly reduce their radar cross-section. This makes them harder to detect and track, giving them a crucial advantage in evading enemy defenses. By minimizing their radar cross-section, hypersonic missiles can evade detection, making them appear smaller and less visible to enemy radar. This stealth capability is achieved through a combination of radar-absorbing materials and aerodynamic designs that minimize the missile's profile. This stealth capability makes it even more difficult to track and intercept these weapons. Radar operators may only get a fleeting glimpse of the missile, if at all, making timely and accurate interception a daunting task. The combination of speed, maneuverability, advanced guidance systems, and stealth technology makes hypersonic weapons a game-changer in modern warfare. These attributes collectively enhance the missile's ability to penetrate defenses and reach its target, altering the strategic landscape and forcing militaries to rethink their defensive strategies. Defending against these advanced weapons requires a fundamental shift in thinking and a new generation of defense technologies. Traditional missile defense systems may no longer be sufficient, necessitating the development of innovative solutions that can keep pace with the rapid advancements in missile technology. This includes the integration of advanced sensors, artificial intelligence, and rapid response capabilities to detect, track, and neutralize hypersonic threats.
Subscribe us to bring insights of inspiring technical innovations.